Hi, welcome back to AQA Certificate Further Mathematics Gcse. Today we're on Chapter 7.6, Finding Solution to Trigonometry. This is a grade A star video and I hope you enjoy it, and let's start. Have you ever thought that there is only one thing that is true about, any question, but actually there are multiple solutions? And prior to my sine rule video, I have demonstrated a real life example that triangles aren't unique at all, and there are two solutions to the same question, but it kind of corresponds to two different triangles. But math is a calculation kind of theory based thing. It's not intelligence. It cannot figure out which one do you want, and so you have to kind of interpret the answer yourself. So remember, learn the graphs, and that is chapter 7.2 or 3, one of them, and that would help a lot. So let's get on with the first example. So question 1, solve sine theta is equal to 0.8. Fairly simple, isn't it? Well, let's use our calculator to its best use and do arc sine is equal to 0.8. Then we can get 53.1301025. Okay, let me drop that down. 53130. I'll have it roughly like that, and I messed up moving that. Never mind. So that is the answer to this question. This is correct, and yet you can only get half the mark for it. You might ask, why? Because this is correct and I'm not wrong. Well, you're correct, but just partly correct. There are two possible solutions, and most likely the question will be saying give the answer for x is in between 0 and 360, or theta rather. Doesn't matter now. A good way to find out how to get the other answer, because the calculator only automatically give one specific output. No matter how many times you click the execute button or the equal button, it will keep saying 53.130 because it doesn't know. It have no idea which one do you want, so it automatically gives the smallest possible value that it knows. The one that is the closest to 0, so it's not negative infinity or something stupid like that. So the way to find out what is the other answer is to use a sine graph given here. How do we look at a sine graph? I have absolutely no idea. Well, to be fair, because sine theta is equal to 0.8, we know that the height, which is the y-axis, will be 0.8, so it's probably somewhere around here, and we can draw a horizontal line through it with a ruler. Remember, use your ruler. Okay, now, so we've got this line. We know there is one answer right here, and we have one answer right here because the line crosses. 53.130 is smaller than 90, so this point is this point. Okay, so that is given. What about this one? Well, if you are smart, or if you are a bit more specific, or if you can observe well, then you can probably see that from 0 to 90, from 90 to 180, they are pretty much a mirror image. So I can pretty much draw a not horizontal, vertical line through this, and we know that those two sides are equal. So since those two sides are equal, we know that this distance from the answer to 0 is equal to the answer to 180 distance, which let me try my best to highlight it to you. So this distance is equal to this distance, and what is the green distance? Well, we've said 53.130. What about this point? How do we find this? Well, because we know this length is 180, we want to know this length. Let's draw it in yet another color. I'm running out of colors. So we want to find this. Nope, overshot. We want to find this distance, but we have this distance. How should we do it? Well, because we know that the green distance is that much, so we basically do 180 minus that distance, which is 53.130, then you can get the answer. So the answer to this question will be 180 minus the answer, which is 126.86989, whatever. And just because rounding off must be correct, who cares? Okay, so now we have two answers. What about things that are higher than 180? Well, when you look at the sine graph, we can be sure that there are only two answers, two possible answers. It can be negative, so these two must be the only solution. So this is a similar question. Solve cosine theta equals 0.3. That is yet another question that is similar to sine, but we know that cosine graph is different, and therefore here I have copied a graph for you to try. Just try it yourself and I'll see if you get the correct answer. So after you've given it a try, let us do it the way that we do. So we know that the answer is 0.3, so the height must be 0.3, so which is something like that. And now we again can find two answers to this question, and the answer that is closest to 0 is 72.54239. And so let me copy that down. And rounding up again, because it's round off. Now we've got that value. What about the other one? So let's observe the shape of a cosine graph. Cosine graph is basically a V shape, and it is mirrored from the left to the right at 180. So we can pretty much be sure that if we cut that in half, then we can get this value will be 316 minus the original answer. So the answer will be 360 minus 72, which gives us 287.458. And I rounded that off earlier this time so that I don't need to just copy and paste out all those values, which is tedious. And we can check for the accuracy of our answers. For 72.54, it is smaller than 90, which is correct. And for the other answer, it's larger than 270, and it is. It's 17.458 larger than 270. So we can be sure that that is a close approximate or the actual answer of that question. And here comes the bane of a lot of students. These kind of equations are ridiculously difficult, and no one seems to be able to get their hands on solving these. My personal preference is to see tangent x as a specific value. Let's say it's u or m. So basically we can see tangent square x as m squared plus 3m minus 4. Okay, so in this equation we have simplified it into something else that is more manageable and more familiar with, and so we can basically kind of factorize that simplified equation into that tangent x plus 4 and tangent x minus 1. So we can solve two answers. Tangent x must be equal to -4 or 1 because one of the brackets must be 0. And because of that, we can find x by using the arctangent function. And if you have the tangent graph, you can sketch one out and press your calculator. Your calculator will have these two answers given to you, but the fact that this is negative is not in range of 0 to 360. So how should we fix this? For a tangent, for a tangent graph, you want to add 180 to your answers. So if you add 180 to -76, you get 104. If you add 180 to 45, you get 225. So surely these three are all the answer, right? Well, no. 104 can add another 180 to make 284, and that are the four answers that they wanted. So yeah, these are the four solutions for x, and this is a not valid answer, so we can delete that. So yeah, the answer will be these four values. Either one will be true. You can test that out, and beware that we have rounded this off. So if the answer is slightly different to 0, consider that to be correct. And so we have solved one of the most common questions on a paper. So there are 3 different rules that we need to remember. The first one being sine. For every sine question, you would like to try to subtract it by 180, or use 180 to subtract it by, never mind, just read the screen. For cosine, you want 360 instead of 180, and for tangent, you want to add 180 or 360 or 720. Anything as a multiple of 180 will be correct, but at most you would have to add 360, and that's all the things that you really need to know about this chapter. So none of my video ends without questions unless it's unnecessary, and I have 4 questions right here for you to solve, and I want a theta in range of 0 degree and 360 degree. Yeah, I forgot the degree sign, but doesn't matter. And also this is all equal to, so there we go, I've fixed the question. Now you have again the classical 5 seconds for you to stop the video and do the questions, and I will give you the answer. So there we go, we have all the answer for all the questions, and the last question only have one answer because it's equal to -1, I believe, and I think it's a sine graph, so it's only it's possible for 270 degree. So yeah, that's is all for today. I hope you enjoy, and I'll see you next time.